Hello. Yeah. Good afternoon, everyone. So, welcome to the project presentation of IssueOps, which we position to be continuous AI for GitHub issues. So, before we dive into the code details, let's meet the team. So, this is the team VAS, which is Vinay, Ashwin, and Sayash. Unfortunately, one team member had to withdraw from the course, which is why you see the extra in the team. Okay. So, oh no, I think Sir has already given an overview of the course, but this is an AI agent assisted course, which is an introduction to cloud computing. So, let's move on to the problem statement. So, what exactly are we trying to solve here? I think, as Mike McQuaid put it very eloquently, we already burn countless unpaid hours triaging issues and dealing with duplicates instead of writing code. So, what we issue ops are trying to do is we're trying to solve this triaging, trying to solve the three problems that I mentioned here. First one is the high volume and noise. So here, large repositories received hundreds of issues. Many of them are duplicate, unclear, or irrelevant, making triaging slow and error prone. The second one is manual labeling. So assigning labels, estimating severity, and routing issues to the right maintainers consumes substantial time. As you can see, there is a 3-day delay before issues are triaged to the right developer. So maintainer burnout. So one thing with a survey has shown is that 59% of maintainers consider quitting due to burnout and overhead of managing issues. So the continuous stream of issues that are coming to the repo overwhelms developers, reducing focus on actual feature development and bug fixing. So let's see the existing solutions in the market. So we compared three tools that are used here: GitHub Copilot AI Triage, Dosu, and Linear. So GitHub Copilot AI Triage is automated AI triaging using GitHub Copilot. So it essentially reads through the issue and then suggests labels priority to the user. Dosu is the closest competitor app to us. So it performs spam filtering, auto issue labels, so, a kind of severity estimation, and component routing. So linear is a new startup available in the market. So it is a competitor to Jira, which occupies 40% of market share for project management. Yeah. So as we can see, our IssueOps solution is able to perform all these features that are mentioned here, whereas the current available market competitors can perform four only at this point. So they're not completely implemented. So for example, component routing. So they're able to suggest components, but it's not able to map to the, for example, what we do is, so GitHub components, let's say front end, back end, all this. So it maps the issues to this particular developer teams. So while this just suggests, we actually map it. So over to Vinay to explain the solution.
So what is our solution? Our solution is a GitHub app and a Streamlit dashboard. Our main focus should be on GitHub app. The dashboard is just an aggregator to show to the user like what the app is doing to the repo and in the background. So yeah, you can download this app and you have to give permission to the app to use the to write and read the repo details. Okay, so how is our solution addressing the three major points that we discussed? So first is high volume and noise. So we use a Llama 3 based spam filtering. For manual labeling, we use Mistral 7B to analyze the context. The context that we are analyzing is the issue title and the issue body. We assign priority, component, and the type in real time, removing manual overhead. Regarding maintainer burnout, we have a master agent that route issue based on the code expertise and the contributing working hours of the user. Like we analyze the past history, past commit history of the user and build a kind of profile. Like this person is responsible or is used to write code regarding this language or this feature. So we map our issue according to that. Okay, so how to get started and use our app? So first go to the installation page, install the app and select the repo you want to manage. Everything else is done behind the back. You don't need to do anything. To know what the app is doing behind the scene, you can check out the dashboard. The dashboard link is given in the README file there. You can you can view analytics and monitor issue distribution. To run manual scan, let's say, so what our app does is it runs hourly issue scans, but sometimes you need to manually trigger. Let's say you're near to a production phase, so you want to like as fast as you can, you want to triage the issue. So we have a manual trigger button also in the dashboard. Okay, so this is our solution in action. So please keep 3 points in your mind. First is high volume and noise, manual labeling, and maintainer burnout. So you can see we have created. So these are 3 spam issue. Uh, Please don't be confused by the first one. The title seems to be like valid, but the body of the issue is kind of spam. We can show you in the demo. Second is triaging. We add labels to our issue right in the GitHub issue window. You don't need to navigate anywhere to a website or something. Uh, Third is notification. If a issue is assigned to you, you get a Gmail notification regarding that. Okay, so this is the dashboard. Uh, we have basically 3 major implementation. First is to give a high level overview regarding numbers and pie charts. Second is to display the full metadata. Third is regarding team structure. Want to add contributor, skill set, and working hours. Okay, what are the metrics? So we did a little bit of research and on top 50 GitHub repos, and what we find is you can see on the y-axis the number of issues created per week uh, in top 50 GitHub repos. So they like balance around 350 to 400. So what is the cost of running our pipeline? So it's around 2.5 to $3 per 1,000 issue. We have a base fee of $10 a month for the EC2 instance. What is the time taken? Time is usually 2 to 5 minutes for 10 issue per repo. Batch processing, but has some cold start. Uh, for let's say multiple repos are using our pipeline, so everything happens in parallel. This is not sequential. What is the accuracy? So initially for classification and triaging, we use our local models. We trained BERT models on the data set, which uh, like got us around 85% accuracy. But during peer testing, uh, our classification model like seems to fail and do not have accurate prediction. So we switch to decoder type based LLMs, which gives us better accuracy. Yeah. About scalability, so we use AWS Lambda function for the backend pipelines and to run the classification. Yeah, I mean to call the APIs, which is highly scalable. Uh, we use for LLMs, we use AWS Bedrock, which is a serverless. So this means the cost is very efficient. You the like you only pay for the compute like at a time. We don't have to run like put the model running all the time. Okay, dashboard is running on a EC2 instance, which is like kind of scalable. Alternatively, the dashboard can be hosted on a private or company owned server. Regarding where this is deployed. Okay, now key feature.
Yeah, sure. Okay, so we explained the 7 key features before. So this is a more in-depth explanation. So smart component detection is we use LLMs to intelligently classify issue content into 7 distinct technical domains, running from front end, back end, DevOps, etc. So then we move on to the second feature, issue classification. So we automatically categorize issues into bug, enhancement, or question. Third one is the priority assignment. So we analyze the urgency to basically assign priority levels as high, medium, low. This map to P0, P1, P2 for those who are working in the industry. Uh, Spam filtering. So spam filtering, as we showed before, it automatically flags and closes spam or low quality issues. Expertise matching. So this is something new that we're doing. So we route issues to the best suited maintainer. So maintainer is the contributor in the repo. So based on the past contribution, as I said, past commit history and their skills. So adaptive workload orchestration. So what we do is that based on recent contributor activity, we determine whether the contributor is available or not, and thereby we dynamically route the task to the best fit developers while enforcing working hours. Yeah.
The pipeline overview. What we've done is for the dashboard, we've used Steamlit as the base for building the dashboard. We've used a GitHub app that you download for classifying the issue. We've used GitHub OAuth so that you can authenticate to the Streamlit dashboard so that you can see only your repos and nothing else. And we use GitHub API to write back to GitHub to write back the labels to GitHub automatically from the pipeline. And this is behind the scenes overview of the 4 pipelines that go hand in hand. The first is the installation pipeline. As soon as some repo or some person installs the app in a repo, it triggers an event and sends the event to a backend, which stores the information, installation ID and other information in a Dynamo table. The second is the issue classifying pipeline. This does the entire classification of the issues. We'll see more about this in the next slides. Stale and SLA pipeline. This makes sure that the issues that are assigned are actually being dealt with. So if a time threshold of say 56 hours process, it pings the assignee by messaging them at the rate their ID and messaging them so that they get a email. And then finally the dashboard. First thing, the installation pipeline. This is exactly what happens in the backend. Someone installs the app, it goes and tags a Lambda function that stores the information in a DynamoDB. Next, that Lambda function uses an event bridge to call the next Lambda function that automatically goes and scans the history of the repo to get expertise of each and every individual in the repo automatically. And this also happens weekly so that the information is not outdated. And this expertise is stored in another DynamoDB table, and this DynamoDB table acts as the source of truth. Next is the issue classifying agent. This is where all the classification and the important stuff happens. What happens is every hour, this pipeline gets triggered, fetches issues by referring to the table, gets all the issues for every repo, then for each repo individually calls the next set of Lambda functions that do the classification, which either add their information to the table and close the issue, or do that at the end. And each Lambda function classifies a subpart of the problem. And then this is the stale issue pipeline. This is also on an hourly schedule. It fetches issues from all the repos and refers to the GitHub to see if they are old enough to be flagged as stale issues or not. It then tries to the GitHub issue tracking table, which issues are closed and which are still pending, and then finally syncs the entire thing to GitHub so that the GitHub and our table where we are tracking the issues are matching and they are in sync. And finally, the dashboard. We use a GitHub auth app so that you can access only the app repos you have access to and only the repos that you have installed the app in. As they mentioned before, you can manually trigger the pipeline, classification pipeline, just for your repo. But this is custom. You can, instead of the past 1 hour of issues, you can take how many hours of issues, so that this allows more flexibility. You can also change the expertise and timings for new joinees because they won't have any history. So you can add members, delete members, and modify the expertise and their working hours. That is the info timings, and you can change them. And then the manual trigger button. Cloud overview. We've used primarily AWS Lambda functions with least privilege IAM roles, which are all connected through event bridges. And then they, when done with the classification, write to our DynamoDB table that acts as a source of truth for our thing. And our entire dashboard, as mentioned before, runs on an EC2 instance. And to write back to the repo, we need credentials of our GitHub app that is stored in AWS Secrets Managers. And then the LLMs used in the pipeline. All the LLMs are provided by Bedrock, hence they are serverless and highly scalable. For classifying the issues, priority, and the type of component, we use Mistral 7B. For finding whether the issue is spam or not, we use Llama 3B. And for assignment agent, we use DeepSeek. All these agents are cheap, fast, and reliable because AWS promises reliability. DeepSeek is a bigger model, so it can have more context length. So that that is required for assignment. These are smaller model. There are only 3 models. So that is bigger. This is smaller because first cheaper, smaller, big. That's more expensive, but it has more context length and is more reliable.
The question. The question is not why one big and other small. Why 3 small? The question, right? But you need Mr. 4B and Llama.
We were just testing between that, and we chose one over the others for these 2. For one of the Lambda functions, we use Mistral. For 3 of the Lambda functions, we use Mistral 7B. For one of the Lambda functions, we use Llama 8B.
Was that a random choice or some informed choice?
Between Llama and Mistral, it was a random choice. For DeepSeek, it was a bigger and better model.
That's fine.
Yeah. So between Llama and Mistral, it was a random choice.
So let's wrap up here for a time. So
Yeah. And then the next, this is the AI agents we used. Ashwin will talk.
Yeah. Okay, so these are the AI agents we use for code development. So you see some stats there. So ChatGPT we use primarily for creating implementation plan. Perplexity we used for research. Gemini 3 for long coding sessions, and Cursor because it is inbuilt to IDI, so we can ask doubts or anything about the code. So how we use agents? So these we use for discussion, basically implementation plan. Code tuning is we provided some code and asked them to optimize it, restructure, etc. And deployment. So since we are new to the deployment field, so we asked agents whether they can help with the development or not. So original targets and accomplishments. So what are the delivered features? So these are the 12 features that we delivered. So we had spam detection, stale issue handling, metadata enrichment, which is rewriting the title or the body of this one issue clearly. Classification, bug feature priority, component detection, which is a new feature that we added, essentially affected areas and then maps it to the skill matching. We build the skill graphs from the commit history of the commit history from GitHub. Availability check, we calculate the working hours from active. Okay. So peer testing results. So we had 4 issues during peer testing. So primarily, the reason why we shifted to Mistral 7B was because we had unreliable performance from a local classification model. So these models were about 300 million parameters. So we shifted to a 7 billion one. So these 300 million parameter models were fine-tuned on GitHub specific issue data. So since we moved to 7 billion, it performed better than this. But one trade-off would be the cost that we had. To replace them with AWS Bedrock Inference. So another issue highlighted was a confusion in the README, which we resolved by refining the documentation. We'd also like to thank the testers, Bhargav and Harsh Saxena, for opening issues and taking time to test the GitHub app. Yeah. So future work, what we like to do is we want to implement duplicate issue detection, which was repo specific, which we didn't move ahead with. And we like to add now. Right now, the SLA rules are manually adjustable, specific. So we want to make sure that the user can put his own SLA rules and then go ahead with it. Thank you.
yeah.
Yeah.
Do you have any questions? We can start with the questions. Yeah, please.
So first thing, a few points. One thing that I liked about your presentation, I compared it to whether it's a novel thing, I don't know. But what you have done is a good exercise.
The truly novel things is these 3. The expertise based last 3, essentially.
Okay.
So none of the other ones, most of the other ones perform it pretty well, but the last 3 ones are something that we decide to make.
The thing is, like other implementation are fragmented there to a little part, but we have combined all together
Yeah.
in a one app.
Yes.
Yeah, the title and the body.
We made sure so that we don't read the contents of the GitHub to maintain privacy.
The actual code.
Yeah. Yes.
No,
No, it like if you gave the app permission to read the repo, it can read the issues. Yeah,
we can do that, but the only reason we didn't do it now is so that to maintain privacy. We say our big repos is TensorFlow can trust us with issues, but they can't trust us with their own private code.
Access to that code.
No, they haven't given. They've only given access to read and write issues.
Then you don't have access.
We don't
Yeah,
have access to
yeah.
it. Yeah.
Not even read as well.
Yeah. But
Yeah.
wherever you get the topic, you can.
yeah. This can be considered future work.
We can do.
Yeah. Currently, we don't have such mechanism. What you are saying is a possible clause, like model can hallucinate and suggest some wrong things. So for that, we can implement one thing for the future scope, like you can manually edit those labels.
Human in the loop escalation is something that we are yet to add.
Yeah.
So you should be adding that if the confidence score is low.
Um, Okay, and why not extend this capability? Suppose you are a committer.
Yeah.
Contribute code. Why not extend this capability? Commit says. PRs, public, pull requests.
We can do the same thing, and the app allows us to do the same thing. But our goal was to stick with issues for this first project.
Yeah.
For now. But it's easily extendable to pull requests.
Yes.
Thanks. Any questions?
Yeah, so one thing I want to point out is that I think you mentioned this already, like all of these things that you're saying is not there.
Yes.
They kind of exist in silos
Yeah.
for specific targeted.
I actually told them to take a look at some of the ops
Yeah.
that's happened in
Yeah.
another team.
The
Right?
sad part is, although it is not already there, it is very easy to, this Copilot and all, they can easily subsume these features.
Yeah, exactly. It's a, these are all sort of the bridge to what will eventually come there. Right? Everything will do everything, but these are sort of the.
So for example, as you're saying, like from our group, we have this work called Triangle, which does incident triaging. And you're
I'm familiar with that.
Yes.
I've asked some. Yeah.
right. So they look at incidents in cloud, not issues in GitHub. But I think like the spirit is same.
Okay.
Jobs.
I told you. Yes.
Yeah.
And then take a look at the Yeah.
But it's a good thing. What you have done is a good thing. I will not take that away.
Yeah, it's a great.
Yeah, but the point is that it's a very hot field. Hot field in the sense that everybody wants to do something about it.
Yeah.
So
So all the projects are the most relevant to the enterprise. Right? So yeah.
And for example, if you triage it to some person based on expertise and
Yeah.
whatever availability and so on. And I think it's aligned to his question as well. Like it's wrong, like, as in like does that particular committer has the option of not accepting that issue, and then what do you read out, Or do you track how many readouts you have done and so on? Is that a
Right now, we
statement?
don't do
all
that.
Okay, so
we had
Yeah.
planned
that
for it,
might
but
be, that might be.
That'll be a good future.
Yeah. I mean, basically the human in the loop for kinds of labeling and yeah. Yeah.
Talking too often, what can the system do to learn better ways to route that? Like more features or better way to analyze the history of the committers and so on. So that could, that might be important if you want to take this further to actually applicable, to be actually applicable in real situations.
Yeah. That can be considered.
Okay, good. Thanks a lot, team. Right?
A quick
Can you-
presentation.
Demo.
Just 2 minutes, that's all.
Yeah.
Okay,
sure.
okay.
It'll take 2 minutes.
25-minute mark. Meanwhile, next team, can you just come on up front and be ready? Log into Teams.
Yeah. So this is the dashboard. We can log in with the GitHub. I have already logged in. So on the left hand side, you can see all the repos for which I have gave permission. So let's open our project. Okay. So you can see here we have total of 5 issues. You can open the repo here. Okay. Yeah. So these are the issue here. You can see there are some pie chart and graphs. Here you can see the detailed metadata. Here you can trigger manual pipeline. You can just like put any number here and it will run. Regarding team and expertise. Okay, let us like we created like 4 issues before the presentation. So let's click a pipeline. Okay. Around in 1 to 2 minutes, we should see some labels here. Regarding team expertise, we can add members here. So let's say I want to add my name. Okay, I'm already there. Okay, let's say test user 1. You can choose from any of the options here. You can write the expertise ourselves, let's say anything, and you can customize like when they are available. So add member. If there is a past
If
commit
they
history.
have past history.
Yes, yes. Yeah. Also, you can delete the members from him. Just write the username. You can rename the member and delete the member also. Okay.
Highlighted the main ones, right? So
Yeah.
you can't get into everything.
So yeah, so there was this is an issue. It has been labeled as bug documentation and high enhancement front end and medium. This is regarding front end center align. Regarding spam, you can see it has already closed spam issue. So let's say on the it sees like valid, but it's a spam. Yeah, it has also flagged the spam, so it has closed these issues automatically. Yeah, and this we also get label design. So like if I open my Gmail here, no, right. So if I see here, like I get the notification. These issue is labeled to me right now. Yeah. On we have tested our project on this repo. No, it's not this. So we have just 2 minutes. No, we have forked one repo and tested on there. So like, yeah. So you can see all the labels and also the closed one. So this is what we put on presentation. So it's a spam. It is closed. Yeah, that's it.
That's it.
Great. Thanks a lot, team. Yeah.
Thank you.
Last team up.